So let's try to apply this idea to something bigger than just our test data, right? So if the challenge this week is to try to use this in some application, we could try using it on like a museum API, for example. So let's try using the same approach, see if this would work for pulling out measurements or something like that that's stored in a museum API. So first we would need to, of course, find a museum API that we would want to use. So lots of museums have APIs nowadays. So let's look at just the Metropolitan Museum, New York, their API. Um, so of course, you have to look at for every API how it works and all the things that are involved in it, right? So they have a few endpoint here. They have objects, object, departments, and search. So objects return individual things, departments return information about departments, and then search is search, right? So you'd want to come through in here and see if there is even like a field that might be good for regular expressions for our use case. We're kind of like searching or chasing a use for a technology here, but normally you'd run into a problem and then apply the regular expression solution. But here we're kind of like looking for where we can apply it. But something like measurements would be good too, because we've already done that, right? All right, so it might be good. They have medium, and then that's separated out individually. And then they also have dimensions. So, dimensions are not separated out into height, width, depth, etc., right? So we could use regular expressions to try to parse their measurements field for their objects. So the key kind of keystone for this project would be, let's type these out, would be the first thing we want to do is, okay, so we found an API. So we need to retrieve some API records, loop through those records, and pull out the, the dimensions, um, the dimensions field, and then we need to parse that with regex, and then maybe store it, right? So we found the API, we need to retrieve some API records, so we need to learn how the API works, and then we need to loop through those records and do something with the dimensions field, and then parse it, and then save it, right? So we need to dive into this documentation to see how the API actually works. So it has this object thing here. So when you pass it an object number, you get these fields back that has the dimensions in it, as from what I understand. So what we need to do is get a list of objects, and they have an objects list here, or endpoint, where you can actually send objects and it will return stuff based on different criteria. So in this example, they're saying, okay, objects endpoint, send back the objects that are in these departments. So that might be good, right? Because not everything is, well, most things will have sizes, right? But like we can narrow this down to something more interesting to ourselves, right? So they do have a list of what department numbers are what, right? So they have photographs, modern art. Photographs could be interesting, right? Because it's a consistent dimension, right? There's not a lot of 3D photographs. They're mostly um, flat. So that might be a good one. We could try to figure out like what average sizes are their photographs in their collection, or what's the largest or smallest, etc. So let's go with that. 19. So department number 19 is their photographs department. So if we go back to their objects endpoint, this example here, they have department 1. And so this is kind of interesting API. Basically, you just give it a department and it sends back, all 20,000 object IDs or whatever. So we're interested in department number, or I forgot it, department number 19. So, right, this is just a web page, so we can see it rendered in our browser. And we can actually just do a quick search on comma and see how many commas there are. So there's 36,000 commas apparently. So there's 36,000 things supposedly, or photographs in that department. Or at least, I guess we could get into tricky areas, right? Because they might have like objects in the photographs department, right? There could be, anti-cameras, for example, in the photographs department. So they're not maybe all photographs. So that might get us later, but we're going to keep going with photographs. So we need to basically retrieve this list of object IDs, right? And so if we have the object ID, then we can use the other endpoints where we just pull back a piece of data for one specific object, right? So if we look at the endpoint for objects, we'd say, okay, here we go. So if we get, here's their example, object/object ID. So we just randomly take one of these photograph object IDs and plug it into here. We'd get a result, hopefully. Yeah, and so here's the result. Here's all those fields that it said it would have. Let's see. This is the empty dimensions field, but this is a photograph of Stonehenge, but it has no dimensions. So we'd have to add some more checks in there and understand how many dimension fields are actually populated, not just empty. So we have a couple options here. We can just run the script to download each one of them and like work with it when it's downloading each one, or we could download all of them and like save them out to a JSON file and then work with them later. So APIs are nice because they're real time, right? So if they change a value in their database and it gets pushed to their API, then it's available in your API in your results immediately. So it's nice that it's real time. For this sort of data, it doesn't necessarily matter if it's up to the minute, right? Because I imagine it's not even up to the minute for most things here. So if you have like kind of like your own cache of the data, that's fine. So what we could do, right, is instead of trying to loop through, make those 36,000 requests over and over and over again to play around with our regular expression, we could actually run that once, save all that data locally, and then just use it locally, right? So that will be a little bit of modification to our plan here, right? So, and store them locally. Because if it's locally, then we can just reuse the data over and over again. It's a much faster rate opening a file off your hard drive than making 36,000 requests to the Met API over and over again, right? So our first, we can think of this as having maybe a couple scripts. The first script you want to do is save all of these items into one file, maybe, or maybe save them all as a kind of a bunch of separate files and then do something with that. All right, so I'm going to get started here. So we're going to head over to our command line here, and I'm in my downloads. I'm going to make a new directory. You can do this in GUI, but I'm going to say make directory met photo. So I'm going to change directory to met photo. And so now I'm going to make a new file in here called download. And so what download is going to do, that's going to be our script, right, that downloads all of these object files to our computer. And you have to be careful when you're working with the API, right? Because if you think about it, so you could make 36,000 requests, right? And it's going to make the request, pull one back, and then you could put them all into one big JSON file, right? But you're kind of putting all your eggs in one basket in that case, right? Because it's as long as the Python program is running, then it's saving the data in memory, right? And then at the end, you're going to write it out to a file. But say something happens, say that your internet connection drops, or Met's internet connection drops, or they block you, or something happens, you would lose all the progress up until that point. So maybe a better idea would be like, you know what, I'm going to make a new directory here called data, and I'm actually going to download each one of those objects and save them as their own JSON file in that data directory. So if it breaks halfway through, It's not a big deal because I already have the first half and I can just pick up from where I left off, right? So uh, that's kind of our approach is going to be, right? So we're going to go back and work on this script. We're going to say, okay, let's import some stuff, right? So we know we're going to import requests because if you know, you can check out the previous lecture about using a request with API, but this is how we work with APIs is through the requests. And we know from the endpoint here that the first step would be to get this big list of objects for Department 19. All right, so we're going to write a request here, and we're going to say data equals or results equals request.get, and then that URL, right? Very straightforward. And then we're going to parse the results of that. So we're going to need to import the JSON module too. All right, so we're going to say objects are going to be equal to JSON.loads and then request.text. And then let's just print this out and see what it looks like. So hit that endpoint with all the object IDs for Department 19, parse that. It's going back just as a big text file, turn that from JSON into a Python object, and then we can do stuff with it, right? So let's give it a shot. I'll run this in our command line, Python 3 download. Okay, looks promising, right? Let's run it again and see the structure here. So we have total, this is a dictionary, see curly brackets, total, and then there's object IDs. So all the object IDs are stored in this key object IDs. So if we go back to our code, we could say objects equal objects bracket object IDs, right? Because we don't care about the total, we just want that list of object IDs. So then now that this is a list of object IDs, we could say, okay, how long is that list, right? And let's try running again. And it's 36,000 things, right? All right, so now that we have this list of objects, we could iterate through them and download each one, right? So we're gonna write a for loop for object ID in objects. And so this is going to be one of those numbers each time. And so for each one of those numbers, we're going to do an object request get, right? So we're going to say, let's call this object R equals request get, and then we got to put the URL in here, right? So we could use a F string, a template string, to plop that in. So we know that the URL should look like this. It should have a public / collections v1 objects and then numbers, right? And then this number is the thing that's going to change each time. So that's going to be in our for loop. It's going to be coming in as an object ID. And so we just replace this with a template string placeholder. And so that will just replace object ID with in the URL string with the actual object number from the API, right? Let's make a counter so we know where we're at after each request. Last thing we'll do is we'll add one to the counter. And now we have the data hopefully stored here in this object R request, the same way we have it stored up here. So we need to do the same idea, is turn it into a JSON file. But if we think about what we're doing, we're not going to be really messing with the JSON data here. We're going to do that next step. So we don't really need to turn it from JSON into Python yet. We can just write it out to a file. But we don't necessarily know exactly what's coming in from the API, right? There could be maybe a couple numbers in there where it's just broken and returns garbage, and we'd want to know that and not parse that. We'd want to know if there's bad data being introduced. And so if we ask JSON to parse every single one of them, we know that it's actually valid JSON and it's working. So we can still do, we'll continue to do this thing where we're turning it into, from text into a Python dictionary. So we'll say object data equals JSON loads, and then this is our results here. So we'll turn the object data from JSON into our Python dictionary, and now it's a Python dictionary. So if that works, then we know it is a valid JSON file, right? And so we could actually be a little smart here and add a try catch, try except statement here. So if this is going to try to do this JSON loads, and if it works, great. But if it doesn't work, then it's going to basically not crash the script, right? We'll say something went wrong with, we'll use another F string here, object ID. All right, so if it works, it'll still work and parse it, and otherwise it will just keep going. And so once we have this as data, what we can do is try to write it. We'll write it out to our file system and just save it for later. So we can use the JSON.dump method, and we'll say with open. We made a directory called data, remember? And then we'll make this a F string too. And so the thing, we'll say object ID should go in there. And then there's always going to be .json. So it should be like data / 12345.json, 12346.json, etc. Right? And then we just need to open that as write mode and point it to a pointer, and then use that pointer in our dump command to write it out to the file. So the thing that we're going to be dumping from JSON is going to be the object data. And we're going to write it here, and we're going to indent it. All right. So if we put a couple things inside of our try statement here, right? So this has to work, and then this has to work. Otherwise, it will just say something went wrong, and then that'll be it. The last thing it does is add one to the counter, and let's just print the counter. Let's put a little status counter, right? So we'll make another F string. We'll say, okay, we're at this position out of the total number of records, right? So it should print like the 1 and then 36,000 or whatever, right? All right, so this is going to keep going as fast as it possibly can and keep writing out that data. So let's see if we made any mistakes and see how it starts up. All right, so it's running. What we can do is go check out the data directory in our hard drive. So I have it open here, and I'm going to drag one of these files over to the editor while that's running in the background. So this is one of the files in the directory. So it looks pretty good, right? Empty dimensions again, so hopefully this doesn't sting us too bad. Here's another one, empty dimensions. Oh, here's one with dimensions. So it's not all bad news. So we tried 3 and at least one of them had it. So we'd have to wait and see how the rest turn out, see if there's enough dimensions. So it looks, of course, like there'll be some dimensions, so we can start playing around with those. So I'm going to let this run for a bit and try to get as many downloaded as possible, and then we'll kind of skip ahead and come back when it's mostly done. All right, so I finished running, and I took a look at how long it took, and it was about an hour to download all these files. So this is in our my directory. I have this Met photo directory, and then I put it into this data directory. So here they all are, and we could use that word count program just to check how many there are. We could say ls list human, pipe that into the word count, and ask for the number of lines. We can see there's 36,757, which is the number we expected. All right, so now we have all of these JSON files just sitting in this directory, and we can go back to our scripts. So we have our one script that downloaded everything, right? And this was just downloading the data from the API and loading it onto the hard drive here in this data directory. And each object ID was the file name plus JSON, so there's all these JSON files. So the next thing we need to do is read these files. And so we'll make a new script because, right, this script is done and we're kind of passing it off to the next step of our process. So I'm going to make a new script called parse.py. And so now this script is going to actually open up all those files and go through them and do something with the data inside, right? And so we can think about how our problems here, right? The first problem is we need to open up all 37,000 files, right? And so how we know that those are on the hard drive, we know they're there. We could do something like we'll ask the API again for a list of the file IDs so that we can know which ones to open up on the hard drive. But that's kind of not intuitive, right? Like, why would we go back to the API to ask for stuff that's on our own computer? And so if you did some research on Python listing files, you would discover that there is a module called glob, G-L-O-B. And so if you import glob, it is a, can't remember what it stands for, but it's an acronym. It's basically a module that helps you deal with finding files on your computer, basically, on the hard drive. And so what it's really good at is that you can pass it like a command line pattern for a file pattern, and it will find all the files that match that pattern in the specific directory. And so if we think about where our script's running, right? So I made a directory called met photo, and then underneath of that directory we have a direct dir called data, and then underneath of that, right, is all the .json files, right? And then we have our scripts. One was called download.py, and then one was called this one, which is called parse.py. So if you think about if you're trying to write a path on the command line to this file, these files and these JSON files, you would say, okay, if you're in this directory, if you're in the metphoto directory, then the path to the JSON files would be data, right? And then all the JSON files, star.json. And so if you did that on the command line, let's test it, right? So I'm gonna here I am in the I accidentally made the parse file in the wrong directory, so I'm going to move the parse file that's in the data directory back to this metphoto directory. So if we look here, we can see our data directory, there's our downloads, and there's our parse. So if we, on the command line, if we did ls data /star.json, it would match all those JSON files, and it's actually saying, there's too many of them. I don't want to list all of them. So that's the path that we would use to get a list of all the files if we're on the command line. So what glob can do is basically very similar. It basically returns a list of the files that you are passing to it to search for. And so you can actually write a for loop that uses this glob tool. So you can say for file name in glob.glob. You just have to read the documentation on how to use this. And then you put the path that you want to search. And since we're running it from the met photo directory, our path would be data /star.json. And so glob is going to look into that directory, find all the files that match this pattern, and then return them as a list for you to loop through them. And so let's just print out the file name for this. So if we head back to our terminal and run our parse, we should see no results. So something didn't work. Uh, it did not find things we're looking for. So data star.json. Um, all right, let's take a look at our code again. Let's just try printing this out. No results. So I would just make sure, oh, of course, so what I did wrong was I moved the file from the data directory and I didn't close it and reopen it in my own editor. So this is a very simple mistake I made there. So let's go back to our editor and we're going to say, don't, I've been saving this and it's been putting it back in the data directory. So I'm going to save this as and put it actually back into the med photo directory instead of the data directory. All right, replace. So I've been running basically an empty Python file this whole time. That's why it wasn't working. All right, so now that the file is in the right place and we are in the right place on our command line, let's try to run it again and see what we get results. Yeah, right. So it went through and it's going to list all the JSON files for us. So that's kind of a big piece of this, right? We now know all the files that we have on our hard drive. So we can actually loop through all the names of them. And then the next step is obvious, right? We're going to want to open them, each one of them. So the next step is we're going to load JSON from a file. And we've done this before, but we're going to want to import the JSON module, right? Because we're using that now. And then instead of printing it, we'll still print it, but let's also open it, right? So we'll say with open and then the file name because we have it ready to go. With that open, let's open it and read as input file, or we could call it JSON file. So with that open, then we're going to ask the JSON module to parse it basically. And we're going to say data equals JSON.load with no S, right? Because it's from the file system. And then here's the file pointer I want you to load from. And so it's going to load that, and let's just print out data and see if it works. And let's give it a run and see what happens. All right, so it's running. And so it's actually going through all 37,000 files, and it's loading them and printing them to the screen. And believe me, this is going much faster than if you had to talk to the API 37,000 times again, right? This will run in the matter of like a minute, right? So it's finished in under a minute. Whereas if you had to spend an hour every time you wanted to try something different with the API to talk to the API and get all those files again, it's much better to have them locally so you can play around with them rather than having to keep going back to the API for your project. All right, so now we know we got a list of all the files, we can open them, and now all we need to do is do something with the data, right? So what we were going to do is look at the dimensions. And so if we look at the structure of these JSON files, it's just basically pretty simple. There's one dictionary, and this dictionary has a bunch of keys in it. One of those keys is dimensions. So let's just print out the dimensions for now and see what happens. And so remember, we're expecting there to be probably a lot of blank fields because we saw a lot of empty, well, we saw a few. And so we'll see what comes back. So I am seeing a lot of dimensions. There are a few blanks. So we could just do a quick test, right? Just to test these, we could write a little simple counter. So we'll say has dimensions equals 0. And we'll just do a little if statement here and we'll say if data dimensions, if data dimensions does not equal empty, right? Because that's what we saw in the JavaScript file. It was an empty string. If it wasn't there, then add 1 to this, and then at the very end we'll print out all the ones that have dimensions. Let's give this a shot again. All right, so 28,000 out of the 37,000 have dimensions, so that's pretty good. That's a decent amount, right? It's enough at least to get to make some approximations or some kind of statements about the collection in general. So the next step is we need to start thinking about writing a regular expression to pull out this stuff, right? So we talked about we wanted to get these dimensions out of the descriptions. And so the only way to do that really is to kind of survey some of the data that is there and then go back and write a regular expression that applies to a lot of them. So let's just get kind of like a sense of what's in there. I'm going to turn off the print statements for most of the stuff. I'm only going to print the dimensions if it's there. And so we'll have kind of like a big block of examples to start with. So let's run that. All right, so we have lots of examples, right? So you can see the variation and stuff, right? Sometimes there's no centimeters, or just inches. Sometimes it says image, so that's how big the image is versus how big the amount of the and image together is. Sometimes it's very simple like this. Sometimes it starts with centimeters. Sometimes centimeters are in the parentheses. Lots of variations of stuff, right? So what you want to do is basically pick a group of these. So I'll just copy a bunch of these. And we're going to go over to our web browser and open up Pythex, the regular expression tool that we were playing with earlier in the previous lecture. And so Pythex is going to let us start writing a pattern for the dimensions data that we had, right? So I'm going to paste that dimensions data in here. And so now our challenge is to try to come up with a new regular expression that matches the centimeter measurements that we wanted to pull out. So there's a big range of stuff, right? But we kind of probably could reuse the same idea that we did before for the example Python or the regular expression lecture. We can see that there's usually a number, sometimes there's a decimal, then there's a separator, and then there's another number, and then there's the letter CM. So we could kind of make a decision here and say like, well, we're just, in this case, we're just gonna mess with the CM measurements. If you were gonna do this much more in depth, you could probably, if it didn't find the CM measurements, find the inch measurements and then convert them to centimeters. But for our kind of, just our demo here, we're just gonna care about the ones that have centimeter measurements. Right, so we're going to write our pattern, right? So we're going to have 0 through 9. There has to be at least one of those, right? And we can see the things starting to match. Then we know that sometimes there is a decimal, so let's escape the period, and there's 0 or more of those. And then sometimes there is a number for the decimal, and there's 0 or more for those. Then there is a space, and there's one or more of those. And then there is this weird divider that look, so here it's an X in one of these, or it's like the multiplication sign here, but then that's just a normal X here. So we were right in our last lecture. So sometimes there is this weird X, and you can see that doesn't match this X. But then other times it's this other normal X, and then you can come through here and make sure that kind of works mostly for what you're looking for. And then you could, just to be safe, let's put a big X in there too. So we cover all our x bases. All right, so then we know that there's an x divider, and then we know that there's a space again, and then we basically just repeat the pattern for the second number. And then we know that there may or may not be a space, right? You could imagine that sometimes you might have like just the CM right up against the number. So let's say that there could be a space, 0 or more spaces, but then for sure, we need to have the letters CM. And then we could even be careful and say like, well, you could have CM or you could have CM uppercase, or you could even maybe even have CM like this, or maybe even uppercase C, lowercase m. There's a huge range of stuff, right? Oh, I think we would have to have these separated out. So we either have an uppercase C or a lowercase c, and then we either have an uppercase or lowercase m or uppercase m. But those have to be there. So if we take a look here, we're going to be looking for things that do not have a green highlight in their line and see what's going on with those. So for example, this one is inches, so we don't have that. Yeah, those look good. So what I would do is maybe just go back and grab a different set of data from a different point in the list, because just to be a little bit more thorough. And then we go back here and put this in instead. And we see if there's any false positives or anything that does not work. These are all inches. So it looks pretty good, right? So in the specific thing we're trying to do today is just pull out if there's a centimeters. This looks like this pattern actually works pretty well for that. All right, so now that we have the pattern, right, the most important thing here is the pattern. We want to put set up our groups for what pieces of data we want to pull out of there. So we know we want to pull out the measurements. So we're going to put parentheticals around those pieces of data, right? And so those should just pull out numerical data that we're looking for. Interesting, this one has an empty match for the second one, so that looks like that might be a problem, right? So let's look for 36.9 in here. All right, so it is, oh, so I made a mistake in my parentheticals here. I was just capturing the decimal point. So I need to move my parenthetical over here. So it actually captures the entire number, not just the decimal. All right, so yeah, it's good to check like that, right? Because I was scrolling through here and I was seeing a lot of no decimal points on the second number. So that was kind of like a red flag that something was not working right. But yeah, this looks good. Seems to be pulling out data. And so now this is the most important thing we have, right, out of this process is this pattern that we've developed. All right, so now let's head back to our script, and we're going to incorporate this regex into our script. So we got to import the regular expression module, and then we need to compile it. So we'll compile it up here because the pattern can be reused over and over again. It's just, it's going to be the same across all the data. So we only need to compile it once. So we'll call the CM pattern equals re.compile. And then this is a regular expression string. And here we go. So now we have the CM pattern. If you wanted to do like an inch pattern, right, you could add that here and have a second pattern defined. And then you can test if the first pattern doesn't work, then try the second pattern, and then try another pattern, etc. Right? So it's not necessarily that you have to write like the one true pattern that matches every situation, because you can try different patterns with it Python, because you have the ability to do this logic checking, right? If statements. And so if we were really interested in doing the centimeter in inches to centimeters conversion, which maybe we should just do it. Yeah, maybe we'll do it. So let's go back to our pattern and write one for inches. And this should be very similar, right? So we just need to change this cm to IN, right? And we should get a bunch of, oh no, this is different, right? Because they don't use decimal points, they use fractions of measurements. So you'd have to write a pattern that incorporates fractions too. Blah, this is terrible. So let's we could try it, right? So we'll try to just to match a fraction based number. So this works for doesn't work for a lot of stuff, right? So we have a number and then possibly a space and then more numbers with a division sign. So let's try to match that pattern. So we have a number, and then we might have a space. We may or may not have a space, so 0 or more than that. And then we may or may not have more numbers with a divide sign or forward slash. We may or may not have one of those, and then we may or may not have more numbers. All right, so that matches this. This matches this pattern. So the next thing we want to do is do our space. You know, we may have one or more spaces. Then we have this x or weirdo x. Then we have another space, and then we have basically the pattern again. Then we have I'm just trying to check here. So then we have basically the pattern again. Let's try that. And it's matching this one, right? But it's not matching this piece here. So it's matching, there's the number. Oh, okay, I think we have to have one or more of this first number, right? So there's always going to be the first piece of the inch measurement. It's always going to be like, it's always going to be 8 and then 3/16 or 11 and 5/16. So we always have to have, so I put this plus sign, so there's always at least one or more. Then we have a space. Then we have a, well, we could have a space. Then we have this fraction garbage. All right, so now we have the 8. All right, so we have that working for the inches. Then we have a space or one or more spaces, 0 or more spaces, and then the letters IN. Ooh, okay, so we have a pattern that looks like it's matching a lot of the inch measurements here. All right, so what we need to do now is, since they are decided to use fractions, we need to break that data out too, right? So we need to know if it's a whole number versus a fraction number versus whatever, versus the width versus the height, right? So basically, I'm going to go through and put parentheticals around all of this stuff. So if we have, we'll capture the whole number of the measurements, and then we'll also capture the fractional amounts sometimes being used, right? So we could have up to 6 measurements, right? The whole number for the inch, then the fraction of the inch, then the second whole number, and then the fractions for the other second measurement. So for some of them like this, it's not going to have a fractional element because it was just 4 inches. But then there is a fractional element for the other one. Ooh, okay, so now we have our second pattern here defined. So let's head back to our script, and we'll make a new pattern called INPattern. re.compile, and then regular expression, and here we go. All right, so basically what we're going to do is we're going to check to see if our centimeter pattern works, and if it does, great, we have our centimeter measurements. But if it doesn't, then we're going to check to see if our inch pattern works, and if it does, then try to do something with that data. So the first thing we need to do is we have the dimensions here. We've been printing them out to the screen. And so we'll try to do this first match, right? So we'll say CM match or CM search equals our CM pattern dot search for the data dimensions, right? So when you do this regular expression pattern, you start with the pattern you're using, and then you're passing the text you wanted to use on into the search method. So this thing will come back and it will have a value. And if it did not work, then it will say its value is none. So we'll say if CM search value equals none, then do this next thing. Else, we'll say we'll have CM width equals none. We'll have CM height equals none. So we're going to say by the end of this file, we want these two variables populated, either by getting it straight from the centimeter measurement pattern or by doing something fancy with an inch measurement pattern. So let's add a little print statement here. If the CM search does equal none, I mean it didn't match. And I'm also sending these to none up here because they don't really have a value. If I set it to 0, that could be true, right? So I'm not saying that they have any measurement right now. They're just none. They don't exist. So if the CM search fails, then it will also equal none. And so that's the case, then we know that we're not dealing with the CM measurement. So we'll say something like we'll deal with that in a second, but we'll just say not CM, and we'll print the dimensions out again just to see what's going on there. But if it did work, then we have the CM measurements pulled out in the two different values. So we know that the CM width, assuming that it's X and Y or width and height measurements, are going to be equal to our CM search. And remember, we're talking about groups. So the group is going to be the first group, right? The first match, or the width. And then we'll say the CM height is going to be equal to the second match. So if that worked, then we should be able to print out the width and height instead. All right, so let's see if this works at all. Give it a run. All right, so it's going, so we'll just control break it at some point and take a look. And so we can see here saying not CM, and then it's giving our measurements and stuff like that. And then if it is CM, then it's just printing out the measurements, the the whole number and the decimal point. All right, so now we know, oh, okay, so like look at this one. This one would never work with our patterns because it says from 3 inches, 7.6 centimeters to 6.5 inches, 16.5 centimeters across. So you would either, you probably, if you wanted to account for that, you'd have to write another pattern that looks just for this sort of format of writing out a measurement. So we're not going to worry about that right now, but we'll go back to thinking about converting this data, right? So now that we have we know that it's not centimeters, we know it's going to be the inch measurements. So we want to test if our inch pattern works, right? So we'll say CM search, or sorry, IN search is going to be equal IN pattern dot search, and then pass the same dimensions text into it. So if we have the IN search, then it's either going to work because it found all the components of the inch measurement, or it's going to be like that one we just saw where it's just like not going to work at all. So we still need to test it and say if IN search equals, or we could say does not equal none, then do something here. Otherwise, you can say not CM and not IN. And we'll just print that on the same line here. You can print as many things as you want by separating them with a comma. All right, so it's going to print that all. If it's not an inch measurement, it's not a centimeter measurement. So if the inch measurement system or pattern did work, then we're going to have potentially we're going to have some variables here, and so let's just print out what we could potentially have. We could potentially have the in search group 1, and if we look back at our regex, we could potentially have up to 6 groups. So 1, 2, 3, 4, and I'm just curious what it's going to be. Let's comment out this centimeter print, and let's see what happens if you run this. Okay, so I ran it, and it says invalid syntax. So I missed a colon somewhere. Here it is. We got to put a colon in your else statements. Let's try to run it again. All right. So for the ones that did work, they are populated, right? So here's one that has, so this is 2.5 by 4 and 1/4, as opposed to this one where it's just 4 inches by 5 inches. So it's not populated. So what I'm not sure what is the value if it's not populated. So that's what I want to check. And so what we can do is test it, right? So we know group 2 is always going to be like that first part of the fraction. And so we could test it. I think it might be equal to none if it does not find, if it's not found. So we'll test that. We'll say if group 2 is equal to none, then print this out. It might be something else though, so I'm not sure. But if it is none, then we should see a lot of, we should only see inch measurements that have the decimal or the fraction part of it. So it is not none because we don't see any here. So let's go back to the drawing board here, and we could test to see if it's something else. Maybe it's just equal to empty string, perhaps. And yeah, that looks like that's what it was, right? So if it was equal to an empty string, then it's printing it out. So that means that there was no fraction measurements. It's just pure width and height measurement. All right, so we can use that to our now advantage, right? So we can know that if if it gets here, then it's just a whole number. And if that is not empty, then it is a fraction number here. So the whole numbers are pretty easy to deal with. So let's do that first, and then the fractions we'll have to deal with that too. So I'm going to pause the video and go learn how to convert inches to centimeters. All right, so I'm back from learning how to convert inches to centimeters, and we're going to get started by just doing the simple ones first, the whole number ones through without the fractions. So if we're going to do the whole number ones, then basically we're going to have the inch height and width just times 2.54. That's how many centimeters are in an inch. So knowing that, we need to get our inch width and our inch height, and then just multiply that by 2.54. And so then that will convert it to our centimeter width and centimeter height. All right, so the first thing we need to think about this is that we are dealing with text when we're talking about regular expressions and that API. So the API is not, that was just a text string and there's numbers in the text string, but it's still text. So we actually have to convert the text to a number. So all those groups that we pulled out, they are numbers, but they're just the text version of the number. So we actually have to convert them to a number. And so what we can do is use the int function to convert those strings to numbers. So the first thing we're going to do is the CM width, right? And so that should be stored in group 1. That's the first measurement that I found. So group 1. So this is, remember, this is just testing if it is fractional. All right, so this is group 1. And we need that to be a number. So we're going to convert it to a number. And then we're simply going to multiply it by 2.54. And that's it. Let's do it for the height too. And you'll remember it's not going to be group 2. It's actually going to be, if we go back to our Pythex group list here, it's actually going to be, so this is the whole number. These are fractions. And then the fourth is the second whole number, right? So the group 4 is the second whole number. So we'll go back to our code and say group 4. And so if this is the case, let's print out centimeter width and centimeter height. Let's comment this out for now, fractional stuff. And let's go and try to run it. All right, so nothing's giving an error, right? It's running through the stuff, so it's not erroring out or anything, so at least that's good. We'd have to double check it to see if like those measurements made sense, but I'm assuming that it does. And so we have basically our inches converted from whole inch numbers to whole centimeter numbers. So the next thing is the slightly more tricky thing is the fractional stuff. But since we pulled it out based on the group number, it should be a little bit simpler for us to deal with. All right, so we know that this is a fraction of an inch, which is equivalent to 2.54. So for example, if it was 1 inch, 1.5 inches, then that would be equal to basically 2.54 plus 2.54 divided by, or multiplied by 1/2, which is the same as 0.5, right? So basically we just need to multiply 2.54 times the fraction results, convert it to a decimal, multiply it, and it will reduce it by that much, right? So we need to figure this out. So we have to say, okay, so we're going to have the width decimal. So the width decimal is going to be the group 2 divided by group 3, right? So group 2 would have been something like, if it was 1/2, group 2 would be 1, and group 3 would be 2. So we would say, okay, turn this number of group 2 into a real number, not a string, and divide it by what's in group 3. Convert it to a number. 3. So the first, if it was 1/2, it'd be 1 divided by 2. If it was, 6/8, it'd be 6 divided by 8. So then we would have the width decimal. So let's print that out. Let's see if it works. All right, so we should look in these numbers and not see anything too wild. We see 0.25, 0.5, 0.65. These convert pretty cleanly into decimals so far. And so now that we have that number, then we know the fractional value of it, right? Because, well, let's do the height first. So we're going to say height decimal is going to be, so 1 is the whole number, 2, 3 is the first fractional, 4 is the whole number, and then 5, 6 is the rest of the fractional, right? 5, 6. All right, so if we have that, then we basically know the formula we can do to do this conversion, right? So basically it's going to be the first one that we were doing before, because we still have the whole number, we also have this fractional thing. So we're going to have this, we're going to put this in parentheses to make sure it goes first, and then we're going to say plus, and then we're going to do our fractional math, right? So we have the width decimal, and we're going to say 2.54 times that width decimal. So it's 1/2, it's going to convert it to 0.5, then it's going to times that by 2.54, then it'll become 1.27 or something, and then that's the fractional amount of that inch in centimeters. All right, I think we did it, y'all. So we'll do the next thing for the CM height. And this is not group 1 anymore, right? This is the 1 is the whole, 2, 3 is fraction, 4 is the whole number. And then multiply it times decimal height, not decimal width. All right, so if we just print this out, we're just curious to see if it runs into any errors. Like, did it come across a piece of data that it could not convert and then it errored out for some reason? Because we tried to do this math on it, but it did not. So let's try it and see if it runs through. And so it did run into some problems here. And it says invalid literal for int with base 10, and then it gave the literal it tried to do. This happened on line 42. So if we look at line 42, what's going on there? So 42 is when it's trying to do the fractional division. And you can see I made a mistake here where I put group 5 twice. So this should not be group 5, it should be group 5 and 6. All right, so let's see if we run it again, if we get the same error. All right, we do. So even though that was a mistake, that wasn't the mistake that broke the system here. So it was saying there is a problem with the literal for trying to do this division on line 42. So what we can do is just print out what's on line 42 before we actually hit the error. We can just print out dimensions and see what it says, right? So it'll Oh, sorry. I just added this print dimensions right above line 42. And so what that's going to do is that it's always going to print the dimensions and then it might crash. And so the last one that crashes on, it will have at least printed the dimensions and we can see what the value is in that dimensions field before it crashes. So let's give it a run. Let's see. Right, so the last thing that it should see is the um, thing that made it crash. And so we we ran into a situation here where we've been thinking about this as either they're both whole numbers or they're both not whole numbers, right? So these are both not whole numbers, but here we have one is not a whole number. It's a 4.5 times 6 inch. So the first part is the fractional. The second part is um, a whole number, not a fractional number. So this kind of changes things a little bit. Maybe we need to have some more if statements here, right? Or maybe we can do something differently. So now that we know what the problem is, by looking at the piece of data that caused the problem, we can kind of strategize around this, right? So we can then think about this in terms of if there is so the first number could be a fractional or a whole number, the second number could be a fractional or whole number. So we could break this down by just doing it by per width and height, right? So just don't worry about both of them at the same time, just worry about one and then the other. So if we do that way, we're going to test to see if, okay, so we're going to do, let's do the width first, right? So is the width a whole number or a fractional number? So we can reuse this and say, okay, if group 2 is there, then it means that it is a fraction. So if it's not there, if it's equal to empty string, then this means the width is not a fraction. Else, the width is a fraction, right? So knowing that, then we can just take our width measurements, our width things we already did, and so this is not a fraction, so we'll set the width here. And then if it is a fraction, then we can just move our width decimal up here. And our width decimal plus whole number stuff, right? So now we went from testing if we assume that if both were a whole number, then they both be whole numbers, but they're not. Or if the first one was a whole number, the second one would be a whole number, but they're not. So this new way, we're testing just to see if the width one has a fraction, and if it does, do something. Otherwise, do our decimal stuff. So then we could say, okay, let's do height. And we're going to say, okay, 1 is a whole number, 2, 3 is a fraction, 4 is a whole number, 5, 6 is a fraction. So if 5 is empty, then it means it's a whole number. So we'll say height is whole number. Else, then this means height is a fraction number. And so we need to reallocate our code for those two scenarios and put them in here. All right, so now it's not assuming that both are one or the other ways, it's actually testing each one, and we can dump this. We don't need this anymore. All right, so if we run it again, we should see if we run into any errors. So if our math is still working. All right. Okay, so we successfully converted inches to centimeters. And if it worked, then CM width and CM height should not be none, right? So if it runs through all of this code and it all works, then CM width and CM height should actually have a value set in it, a number value, a decimal, if it got through one of these logic if statements. So if we run this now, we'd see the true things that are not decimals and not or not inches and just don't match either of those patterns. And we can see what's going on there. So you probably would maybe want to write some patterns that check for these things. If you wanted to get all the edge cases right, so you would write a pattern that matches this kind of phrasing where there's in inches and centimeters and inches again, then centimeters. You can see here that this one, they did not use a forward slash, they use the actual 1/2 fractional character. So you'd want to write a pattern that checks for that. Happens a lot. And you just go through, because most of these are actually, they are inch measurements, but they're just formatted in ways that we didn't write the pattern to account for, right? All right, so, and here they actually use fractional decimal inches. Cool. So this is kind of like the problem with data, right? It is always going to be in a format that you don't want it to be in, and then you have to figure out how to get it working for your purposes. So we could spend another half hour writing edge case patterns for all these other things, but it'd be the same idea, right? You write a new pattern that works for this specific thing, then you incorporate it into your if statements to make it work. But I think we're pretty much at the point where we have our data. So if we want to make sure if it has dimensions here, and then we're going to say if CM does not equal none and CM height does not equal none. Now we have some data available to us. And so we can do all sorts of stuff with this, right? Let's just do so we can, so if we have CM width equals to none and we have CM height equals to none, then we know that, this is at the bottom of the for loop, and the dimensions are not equal to none, and these were populated. So if we get to this point here, we have some data to work with. So now we can decide what we want to do with this information. You could do all sorts of stuff. You could look for the biggest things. You could look for the smallest things. You could maybe do a count, right? We've done that before, so let's do a count. We'll do measure, or we'll do like size lookup. Right, and so the size lookup is going to be an empty dictionary, and we'll make a string as our key. So we'll say lookup key is going to be equal to CM width CM width is in our little special F string brackets, and by CM heights, right? So we'll make a string that is basically 10 by 4 or whatever. And then we're going to check to see if lookup key is not in our size lookup, then make sure it's in there. So we'll say size lookup key equals 0. And then we're always going to add +1 to lookup key plus equals 1. And then so that should basically build a lookup dictionary of all the numbers of the sizes. If we run that, let's see what it looks like at the end. Let's write it out to a JSON file. So we'll say with open size results.json for write out as write out, JSON.dump the size lookup to our out file and then indent it a little bit. And let's run it again. So I wrote it out, so let's open the file in our editor just to see what it looks like. And so, of course, you could sort this, right, to get the most common sizes, but it does look like it worked, right? There's a lot of variation here. There's lots of fractional things. You might even like want to add some code that maybe just rounds it to the nearest whole number to kind of give it a little bit more uniformity, or at least round it to at least one decimal point and not have it to, be 99999 repeating, which happens when you turn fractions to decimals. But yeah, it mostly works, it looks like. And you could see there were definitely some common sizes that were the most prevalent, like 7.9 by 7.9 square, right? These must be probably common photograph paper sizes. So yeah, so you could do all sorts of stuff, right? You could try to find one that is the biggest, like here's 50 centimeters. All sorts of stuff. Oh, I saw one that's like 428 centimeters, right? So is that an outlier? Is there really a 428 centimeter photograph in the collection? It'd be interesting to see. You could check to see if it's bigger than 100 centimeters and then print out the title, etc., stuff like that. So this should get you started. The source code of this will be available too on the sites. But this should be kind of a good example to get you started working with regular expressions and then thinking about how you would actually apply them to a different data set, right? So we used an API result here, so we had to go through that extra step of actually getting data out of the API. But what if this was just a CSV file? Then the first step would be just loading the CSV file and running through it. So the regular expression part was separate, right? So we have like two scripts. One was the download and one was the parse. But that's a good way of thinking about getting data and then setting up a kind of like a workflow or pipeline to process it and work with it. So thank you for watching, and I will see you later. Bye.